All right, here we go with some in-class review. First, we're going to do long division. So I will give you the option. You can either follow along with me here as I do the problem, or you can pause the video, try it on your own, and then see if you get the same answer that I do. First, we're going to set up the long division. Okay, so that's my long division setup. 9x minus 4, 36x cubed minus 79x squared plus 55x minus 14. Okay, first step, divide. Remember, it's divide, multiply, subtract, repeat. So I'm going to divide 36x cubed over 9x, and that is going to be 4x squared. That goes up top. Remember, the result of the division always goes up top. Now we're going to multiply. 4x squared times 9x is 36x cubed. These should always be the same. And don't forget 4x squared times negative 4 is negative 16x squared. Now I'm going to subtract. Notice that negative 79x squared minus negative 16x squared actually becomes plus. This should always cancel. So negative 79 plus 16 is going to be negative 63x squared. These were zeros, so I still have plus 5x minus 14. Great, that was one cycle. Let's repeat. Now we're going to take negative 63x squared and divide it by 9x. Negative 63x squared divided by 9x is going to be negative 7x. Write that up top. So now multiply negative 7x times 9x, negative 63x squared. Good, those are the same. Negative 7x times negative 4 is positive 28x. Now I'm going to subtract. So I have 55 minus 28. This is going to cancel. So 55 minus 28 is going to give me 27x. There's a 0 here, so this is still minus 14. Sorry, that's a minus. Now, let's repeat again one more time. 27x divided by 9x. Move this down a little bit. That is going to equal 3. I'm going to move this up a little bit. So we'll go plus 3. All right, multiply. 3 times 9x, 27x. 3 times negative 4 is negative 12. Now we are going to subtract, and that should cancel. Negative 14 minus negative 12 is negative 2. Now, I can't divide anymore. I've got a remainder of negative 2. I can see my answer here. So I'm going to write my answer is 4x squared minus 7x plus 3 plus negative 2 over 9x minus 4. Wasn't that fun? All right, let's go on to the next one. Here we're going to go ahead and do synthetic division. Now, again, I'm going to just work through the problem, but if you want some better practice for yourself, I would go ahead and pause the video, try to do it on your own, and then watch my solution or explanation to make sure that you did it correctly. Even you could fast forward to just the answer and check your answer, and then if you don't get it, then back up and see where things went wrong. Okay, so I set up my synthetic division. Remember, with synthetic division, we add vertically. There's nothing below the 2, so that's just going to come down. And then we multiply diagonally. 2 times 2 is 4. Negative 3 plus 4 is 1. 2 times 1 is 2. 6 plus 2 is 8. Great, that was fun. How do we write our answer, though? Good question. Glad you asked. So remember, this was a degree 2 polynomial. Therefore, our result, our quotient, is a first degree polynomial. This will become 2x plus 1 plus our remainder, 8 over x minus 2. Look at this fun little pen. That was great. Any questions? All right, moving on. Let's try the next one. All right, this is getting a little repetitive, but again, if you want to pause the video and try this on your own, that would be probably more beneficial, but I'm not going to make you do that, so it's really up to you. Okay, so here we are given this graph, right? We're told it's a fourth degree polynomial. Great. We are told that the leading coefficient is 1. Now, that just means the value of 1, and we're going to see it doesn't mean it has to be exactly positive 1. We want to write the equation of the function in factored form. So the first thing we need to do to find factored form is we need to identify the roots. So I can see that I have 3 roots. However, notice that this root here has what we call the bounce, right? So that bounces off the x-axis. That means that it has a what? Multiplicity of 2. Excellent. So the first thing I'm going to do is, after I identify the roots, I'm going to write the roots as factors. So if x equals negative 2 is a root, then x plus 2 is a factor. Now, because of that bounce, that has to have a multiplicity of 2. X equals negative 1 is a root, so x minus 1 is a factor. X equals 3 is a root, so x minus 3 is a factor. Awesome. I have 1 to the second, or x to the second power, x to the first power, x to the first power. If I add those up, I get a fourth degree polynomial. Now, the thing that I was talking about at the beginning was, all right, it's that our leading coefficient is 1. However, notice that our end behavior is down, down. And when we've talked about end behavior before, we know that if there is an even degree, so 4 is even, and a negative leading coefficient, then our end behavior will be down, down. So I need to throw a negative in front of that whole thing in order to get the correct end behavior. Great. Moving on again. Okay, here we want to state the intervals for increasing and decreasing and state the ordered pairs for maximums and minimums. Again, pause the video if you are adventurous and want to try this on your own. First, let's identify the maximums and minimums. I can see those here. I have 2 minimums. So I have a minimum at negative 1, comma 0, and at 1, comma 0. And I have a maximum at 0, comma 1. Coincidentally, those are also our roots. We don't care about this for for this problem, but it's just something to pay attention to. And coincidentally, this is our y-intercept. Now, let's look at increasing and decreasing intervals. So increasing, it's increasing here, and it's increasing here. So it's increasing from negative 1 to 0 and from 1 to infinity. Now remember, I want to emphasize this right here. This is an interval. So both of these represent x coordinates. This is not the point negative 1, 0. It is the interval from x equals negative 1 to x equals 0. The function is decreasing here and here. So it's decreasing from negative infinity to negative 1 and from 0 to 1. Again, these are intervals. Every single number here represents an x coordinate. Next one. Okay, so here we're going in the other direction where we're given the information about the polynomial and now we're trying to actually draw the sketch. So let's pay attention to or identify some of the important information. So our end behavior, remember that comes from the degree and the leading coefficient. So if we know it's a fourth degree polynomial and a positive leading coefficient, then my end behavior is going to be up and up. A root at 1 and a root at 4 and a root with a multiplicity of 2 at negative 5. So the first thing I would do, if you're confused on how to start this and don't want to try it on your own, is let's plot the roots. So I have a root at 1 I have a root at 4, and I have a root at -5. Now the root at -5 has a multiplicity of 2, so what does that mean? That means that I'm going to have some sort of bounce there. Now I know that the graph has to go up and up to the left and to the right because of my end behavior. Therefore, I'm going to draw something like this. Bounce through, and up. Lovely. Next one. Is x plus 4 a factor of f of x equals 4x cubed minus 2x plus 1? That's a good question. How do we figure this out? Well, there's two main ways we can figure this out. Again, try it on your own. I'd recommend that. If you don't want to, just keep listening to me ramble. It's probably more exciting that way. So, what are the two ways? I'm going to actually go through both of them. The first way is synthetic division. So if x plus 4 is what I'm trying to figure out is a factor, I'm going to use -4. Then I'm going to put 4. There is no x squared term here, so we're going to put in a 0. Then -2, and then 1. Now, let's back up a second. So I'm using synthetic division. How is this going to tell me if x plus 4 is a factor? That's a good question. What is it that I'm actually looking for in my answer? Just that I can do synthetic division? Because actually I can do synthetic division. I know that without doing the problem. No, what we're looking for is our remainder to be 0. So if I get a remainder of 0 from my synthetic division, then I know that x plus 4 is a factor. Let's go ahead and see what happens. I'm going to add, so 4, -4 times 4 is -16. 0 plus -16 is also -16. -4 times -16 is 64. -2 plus 64 is 62. Sorry, the colors. And -4 times 62 is going to be -248. -248 plus 1 is -247. That is not a value of 0. Therefore, no, x plus 4 is not a factor of 4x to the third minus 2x plus 1. Now, at the beginning, I told you, well, there was two ways that I could go about this problem. The other way is because of our remainder theorem, I can actually plug in -4 to the function. So let's look at that. If I do f of -4, again, what I'm looking for is to get a value of 0. So this notation, remember, just means that everywhere there's an x, I'm going to make it a -4. So if I go ahead and type this into my calculator exactly as it's written, I know, because I've already done the synthetic division, that f of -4 is going to be -247. Again, it's not 0. However, if this came out to be 0, which means this would have had to come out to be 0, then I would have been able to say that x plus 4 is a factor. Now you might be asking yourself, well, why would I ever do the synthetic division when I can just plug in the number to determine if it's a factor? And that's a good question. If all you're trying to do is determine yes or no, is something a factor of something else, then just plugging the value in is great. However, if you're trying to determine if something is a factor and then find other factors, or if you're just trying to find other factors, then the synthetic division is more useful because we can take the quotient and continue to break down the polynomial to find other factors. So the synthetic division is still very important. Okay, I'm going to end this video here and then go on to part 2 to do the remaining problems.